So I'm Marc Baldo, and I run a group called the Soft Semiconductor Group, and we look at materials for LEDs and solar cells. The biggest intellectual obstacle in our research is the fundamental difficulty of doing science on systems that are so complicated. How do you design a clean experiment? How do you do a test that yields a definitive answer? When you're choosing projects and you're trying to manage the risk, you've got to look at the potential outcome. It's worth taking a risk if the outcome is good and you've got enough different projects in your group with different risk levels. We try and spend an awful lot of time in the design of what we're going to do and not just take, loads and loads of data that then we have to try and process. Our lab's split into two parts. We've got a lab in Building 13, which is where we do fabrication. And so we make devices in there, and then we take them over to another lab in Building 26, where we measure them. And that's an optics lab with lasers, and it's dark. We try and use molecular materials. So we try and make devices out of molecules. So the chemist will make a little molecule, and then we deposit these things in a film. And then in the example of an LED, we put contacts on that. We drive charges into these molecules, and then they emit light, and we control what happens after that. We also use that same technology to work on solar cells. And the reason we're interested in that is because the molecules you can just coat on stuff. So you can take any old substrate. We can make transparent solar cells, or we can make solar cells that fit into windows. They look like big, flat collectors of light, and they redirect the incident light to the edges. So they could be black or they can be transparent. And so that's what it's all about for us. Can we take advantage of the ability of these molecular materials to just coat things like dyes? They're like dyes and paints, basically. Can you just coat stuff with paint and make electronics that way? And then, does it work? Is it stable? Is it efficient? That's the basic problem we're trying to solve. The best part of my job is interacting with the students and seeing them come through with some really cool piece of data. Graduate students are the core to any research group, I think, in engineering here. Because they're around for 4 to 5 years, they have the ability to get really stuck into problems. So the first few years are training, and then they have a couple of years where they're incredibly productive. When I came here, I thought that scientific groups just ran a particular way. I came from a group that had a very strong scientific culture, and I just assumed that was just the way it was. I realised that actually you've got to kind of develop it, and it's very hard work to get a culture where everyone in the room is going to address one another's ideas and debate whether it's a good or a bad, where it's not just everyone working on their own project, but where everyone in the group is thinking about all the topics together. For undergrads, what we try and do is give them a sense of, is this something you want to do with your life? Do you want to work in this kind of environment? And we try to give them a taste of what research is like, if they can participate in a paper or work with the grad students in building equipment, but hopefully get on a paper somewhere. The other things I try and do is when I teach a class to the undergrads, I try and throw in some of the ideas that people are thinking about, so that undergrads can see, actually, I'm not very far removed from the problems that are captivating everyone today, the actual cutting-edge research problems. And I try and explain, I want the undergrads to know, they're really close to this, to working on, absolutely having the maximum amount of knowledge that anyone in the world has. RLE sets up a very flexible space for us to work in. There's no restrictions at all, really, on what kind of problem you might want to work on from RLE. It provides space, and it sets up a culture within MIT that's very collaborative. The scale of MIT and RLE is also a big help, and that's another good aspect of MIT. Because the department is so broad and it covers so much ground, it forces you to understand a lot of different things, and you can start to see connections between things that you wouldn't have otherwise understood. I like the fact that engineering gives you a lot of freedom. It's a problem-driven discipline, if you like. So, the important thing in engineering is, are you working on an important problem? And then the question is, you don't have these issues like, well, is it physics or is it chemistry? Does it fall into these discipline boundaries? And we don't really worry about that. It's like, well, is it an important problem? Can I make some kind of impact on that problem? If the answer is yes to both of those things, then it's something we'll look at. And then the fun part is, you know, trying to make some progress on that problem. I think the most important thing is to ask, you know, about stuff you don't understand. Have the confidence to say, look, I don't understand that. Can you explain that? Because quite often it's that question that actually opens up, you know, what the real problem is. Or an even more important question is, why are you doing this? You know, it seems like the obvious thing, but why are you doing that project? Why are we working on this? What problem are we actually solving? That fundamental question is the most important question, and quite often it never really gets asked. And so, you know, I hope if we're successful, everyone knows why they're doing what they're doing and what the potential impact is and where the things that we don't understand are. When you do good science, when you're doing good work that's new and you're breaking new ground, it's going to be useful for someone somewhere. And it can be very difficult to predict exactly how it's going to happen. But it's nice to be part of that big challenge, and it concentrates your efforts on solving real problems and not just doing topics that you can publish papers on but may not have any real contribution.